We are going to be talking about some of the cross-linking type of reactions that take place in phenolic thermoset resins. And this is going to give you an idea of what kind of byproducts are created, as well as what kind of uh, processing is required in order to get fully dense type of composites. You know that if the composite is going to be porous and it has got several porosities and things like that, it is not going to be the best type of composite um, that you can get for mechanical properties. So these reactions can be carried out under two different conditions, and you can get two slightly different cross-linking type of sequence. And in both the reaction sequences, you have an intermediate that is formed, and you stop the reaction at that stage. So why? Because you need to be able to handle the resin at this stage. So what happens is that you get either a prepreg or a resin that has been processed to the intermediate stage, so that it is easy for you to use it for the next stage and the final curing stage. So these types of resins are called B-staged resins. And that's what you will find available in the marketplace. And the resin manufacturer will stop this reaction, and he or she will ship the material to you for the final curing and molding. So if you have A stage, that is what you start with from the beginning stage. It is totally unreacted material, and they are just usually monomers. B stage is the intermediate material, and C stage is fully cured and cross-linked. So prepreg, if you have a prepreg, they are usually called B stage. If the A stage material is supplied, then the reinforcement and the resin is supplied separately. So you have different types of phenolic resins. It used to be manufactured by Borden. It used to be called Durite SC1008. And now the supplier might be different. I believe it could be, I don't remember the exact manufacturer. It could be Hexion, or it could be, what is that? It starts with M. These are the suppliers of phenolic type of resins. And the first stage, the first type is usually supplied in an excess of alkali, or some kind of alcohol, and the concentration of that carrier is usually greater than the concentration of the phenolic reactant. So it will take you a long time for all the solvent to be removed completely. And then you have to remove the reactant products. It can be controlled to produce a viscous liquid of intermediate product. It's called a resol, and it is minimally cross-linked. So these are, the first kind is usually supplied in a solvent such as isopropanol, or not usually acetone, but isopropanol. But even this isopropanol is not the best material for handling. So you can't let yourself or your technicians to be exposed to this material, but you need to drive off this solvent during the curing process, which can slow down the curing reaction. And you can cross-link it, complete the cross-linking reaction by simply reheating it up to 300 degrees Fahrenheit or 150 degrees centigrade. There is If it is a result type of reaction, you don't need to add any kind of additional material to it. So these are usually called one-step resin. Sometimes you also add some kind of an acid catalyst to accelerate the curing process. The major problem with the phenolic resins in general is that there is a byproduct that is caused as water, and if you are careful, you can remove the water very easily, but most often, if your component thickness is greater than, say, 1/8 of an inch thick or 1/2 of inch thick, what happens is that the amount of steam and water that is held between the prepreg or between the fabric layers is going to be difficult to be removed. So you got to be extremely careful to get full densification. So you need to extract this water completely and perfectly. It is done with difficulty. This is a very, very difficult process, but it can be done. So the other type of reaction, other type of resin is called the Novolac type of reaction. So in this case, the phenol is in excess compared to the formaldehyde reactant, and an acid solution is used. So these conditions are opposite of those used to form resoles. And it is usually a non-cross-linked polymer in the form of a powder. And many times this is soluble in water. So you can use, so it's much easier for you to form the reaction and to complete that reaction. It will not cross-link with just the addition of heat, but it will require a curing agent. And in this case, the reactant, the curing agent, is hexamethylene tetraamine, or it's simply called hexa. It is heat activated, so molding of Novolacs is usually done with pressure and heat to compress a powder and activate the cross-linking reaction. So a Novolac type of a phenolic resin is usually called a two-step resin. A resole is called a single-step resin. And the other interesting aspect is that the Novolac type of phenolic resins can easily be converted into epoxy and vinyl ester type of resins. And Novolac phenolic resins are often sold as solutions, and the most common solvent are water or alcohols such as ethanol, or it can even be dissolved in toluene. During the cross-linking process, these reactants or the solvents need to be evaporated very carefully. So solvent evaporation is one of the main drawbacks of using phenolics in composite applications. Or if you have a resole type of a reaction, the single step resin system, the water that is formed and as well as the solvent that it is in, it is difficult to remove that. So if you go into a place where they produce phenolic type of components, that place will be floating in some kind of a, however hard you try, it's going to be smelling of that solvent. So you got to be using all kinds of protective gear and things like that. So what is the problem with water byproducts in the condensation cross-linking reaction? It occurs in both resoles and Novolacs, and it is formed throughout the polymer mixture. So if you are not careful and if you don't remove it completely, it can form small bubbles and voids in the part. So if you do a cross section of your component, if you see that there are big holes in there, that shows that you have lots and lots of moisture that has been formed and it has not been removed completely. So the common practice when you are doing compression molding is a process called bumping. So what do? You can apply pressure in a hot press or a carver type of press, and you open up the mold above 100 to 110 degrees centigrade, or about 200 to 240 degrees Fahrenheit, and then you let that water escape. So it will just like a steam engine. Okay, so it will just remove that moisture or steam. Boom, I mean it does that, and then you put it back again. I mean close the mold again, and you may have to do that multiple number of times, especially if you want a component that is completely devoid of any kind of um, porosity. And then you cure it, post cure that about 160 degrees centigrade between 1 to 24 hours. If it is a thicker component, then you will have to do this for a longer period of time. But if it is a small, not a very thick component, you can do that within a couple of hours. And then usually what you do is you leave the component inside the mold itself and let it cool down inside the mold. So what are some of the properties of phenolic resins? They have good chemical resistance, they have good resistance to alcohols, and many types of solvents and acids and things like that, but they don't always have very good resistance to very strong acids. And it also has very poor resistance to boiling water and poor resistance to UV. So what do you have to do? If you are making a phenolic type of a component, you have to add additives such as carbon black in order to improve the UV resistance of these composite materials. Flammability is the most important property of phenolics and phenolic composites. And some of the other applications are, it is used in aircraft interiors, and the main defense application, because it has got fantastic ablation resistance, so it is used in the exit nozzles of rockets. So now we are going to talk a little bit about different kinds of manufacturing processes. The most common process and the easiest process is hand layup. So you do that by hand. So what is going to be the problem with hand layup? Consistent properties. So, but if you want to make it for the first time and see how well you can, what kind of properties you are going to get, then you can do a hand layup. Okay. So what you do is you take the mold and you apply some kind of a mold release or gel coat, and then you apply the fiber or the fabric, and then you pour the resin, or if you are having a pre-preg, then you can just lay it down, and then you apply pressure. So most of the time these are two-part molds. So it's not a single-sided mold. These are two-sided molds if you want to apply compression molding. The next manufacturing process is spray out. How do you do that? You chop the fibers, you add it to the resin system, and then you spray it. So the catalyst resin and the continuous strand roving are usually separately held, and you apply the strand roving and then you apply the resin system on top of that. As soon as it hits that, it gets stuck and holds it in place. And then you apply the pressure or you cure it, and then you get the final shape and form that you want. If you want, these are all for cases where you have small batch numbers or small numbers of components to be built. If you want large numbers of parts to be built, continuous manufacturing process, process called pultrusion is used. So what you do is you have a continuous section. Say for example, if you have a channel, or if you have an edge section or an eye section and things like that, you can use this kind of a process. and the continuous fiber tows pass through a resin bath containing a catalyst, and then the impregnated fibers pass through a series of wipers, so it removes all the excess polymer, and then it enters a heated die, and at the end of the die you also have some kind of a nozzle or a die, and it takes it through that, and then it is compressed at that point, and as it is compressed it is pulled out of that nozzle, and then you have a saw that cuts the product to a fixed length. So you can't have very complicated shapes, but if you want simple shapes, then this process is extremely amenable to that. So if you have um, lots and lots of components to be built, very standard size type of components to be built, you can use this kind of a process. So you have, say for example, this one is a helicopter windshield post. It's carbon fiber wine luster, so it's about 1.5 meters long. So if you want to make it by hand layup, it is going to take you forever and it's going to cost you a lot. So if you have pultrusion, it helps you to reduce the cost. Okay. So this is the schematic of the pultrusion process. The next kind, if you want to make consistent composites with consistent properties, you can use a process called filament winding. You need some kind of a shape around which you wind the fiber that has been resin impregnated, or you take a pre-preg in a precise geometric pattern, and you can control the winding patterns and things like that depending upon the final property that you require. You rotate that mandrel just like a lathe. Okay, you rig up a lathe. It's a glorified lathe that you use as the main mechanism for making the composite parts. So if you want to make tanks and things like that, this is a very standard process that is used for that. So here is a mold around which you wind the fiber, and these fibers can be either wound in a figure of 8 pattern or a cylindrical pattern or some kind of a extremely complicated shape. So you can do that, and afterwards you will have to remove this mold. And there are many ways to remove that mold, and I will talk to you about all that in the future lectures. The next kind is resin transfer molding. It's a closed mold, low pressure technique. The fiber preform is placed in a mold, and you inject the liquid resin into the mold by a pump. So which means that you need a very low viscosity resin system. So you can use thermosets and polyester, but sometimes you have to dilute it with a solvent. Can you make thermoplastics with this? It can be, but it is extremely difficult because thermoplastics have very high viscosity and it is difficult to process by resin transfer molding. So now let's talk a little bit about processing. So let me stop here and continue with the next set of slides.